Hey guys, welcome back to your Chapter 7, Section 2 video. This is me, Mr. Lewis, your teacher again, talking about some physical properties. Let's get physical, physical. I want to get... No, never mind. That's another song from back when I was a kid. Physical properties is our song, is our story today. On the screen right there is your bell ring here. Go ahead and answer that. You know where to answer that at? It's on edmodo.com. Let's go ahead and get started with this show here. All right, today's our objective. Today you're going to identify 6 examples of physical properties of matter. You're going to describe how density is used to identify substances. You'll list 6 examples of physical changes, and you'll be able to explain what happens to matter during a physical change. That is what we're going to be talking about today. So let's go and get started. When we talk about physical properties, what are those physical properties? Well, physical properties are the things that you can observe. They're easily for you to observe and to be measured without, and this is the important thing, without changing the matter's identity. Okay, so physical property of this would be that it's blue, all right, because there's blue on there. It has a screen. It has black right here. There's silver on it as well. That's physical property. This is in a shape of a rectangle, rounded off corners of a rectangle. That is the physical properties of this. It's made of rubber. It's made of plastic. It's made of steel. All those are physical properties. There's things we can observe and things that we can measure, and it did not change the identity of the matter. That's the important thing to keep in mind. So here we go. Here's an example, or here's a chart, so you can see some examples of what we're talking about physical properties. Now, these aren't the only physical properties, but these are 6 physical properties that we're going to talk about throughout the rest of the year as we keep talking about substances. All right, or different forms of matter. First is going to be thermal conductivity over here. Now, thermal conductivity, it says, is the rate at which substance transfers heat. So in other words, it's the rate at which substance, anything that you hold, transfers heat. So it's interesting, like if you have tinfoil. All right, you know how when you hold on that tinfoil, when the tater comes out of the oven, that tinfoil is hot. But you take that tater out, the tinfoil all of a sudden gets real cold. All right, very quickly. That is thermal conductivity. In other words, the rate at which that substance transfers heat. All right, and you see there it says plastic foam is a poor conductor. All right, next is the state. This is another example of physical property. State is the physical form in which substance exists. In other words, is it a solid, a liquid, or a gas? That is what we're talking about as state. So if this right here, it is a solid. That's what the state of this is. The air, the oxygen coming out of my mouth, or the carbon dioxide coming out of my mouth as I'm breathing, that is a state. That is a physical property. That is a gas. Okay, if you take that water, you put it on a stove, and you turn the stove up on it, it's going to bubble and boil, and there's steam coming off of it. You have gas and you have a liquid. Those are all physical states of a substance. Density is the mass per unit volume of a substance. In other words, how much mass is in that particular substance. Okay, that is a good example. So lead right there. When people say, talking about a lead balloon, it flies like a lead balloon. A lead balloon will not fly because lead is way too heavy to fly. So that is lead. Solubility, in other words, the ability of the substance to dissolve into another substance. So can you take something like Kool-Aid and put it into, which is a solid, Kool-Aid is a solid, you put it into a liquid container and it dissolves into that water, all right, that container full of water, it dissolves in that container, the solubility of that. Or if I were to take this pin and I were to put this pin inside of water, would this pin melt or dissolve into the water? No. So we talk about solubility. Ductility is the ability to pull something into a wire. All right. Now, when we talk about ductility, it is something we typically talk about metals and stuff when we talk about ductility, because you take a chunk of metal and you can, with enough pressure, enough force, you can pull that into a wire. The copper wire you see right there on the screen in that picture, that is an example of ductility. In order to get that wire, they actually had to take a copper chunk and put it through a machine that pulled that copper chunk into that thicknesses of wire. And last is malleability. Malleability is the ability to pound something into sheets, okay? So, and it still remain that substance. So when we talk about ductility and malleability, we really talk about metals, because metals are the main ones that are ductile and they're malleable. All right, in other words, they're able to be pulled into a wire and they're able to be pounded into flat sheets, okay? So when we talk about physical properties, we have to identify the matter. All right. So you use physical properties to help us to identify matter. So if I wanted to know the difference between these two objects right here, all right, I could use physical properties to explain them. Number one is a lot larger than the other. One's a rectangle, while one is more circular or oval in shape. One is made blue, black, and silver. The other one is white and colorful with different colors, and so white, green, blue, other colors on it. So those are physical properties. Those help us determine the differences in substances. We can identify matter by its physical properties sometimes. Density is the amount of matter in the given space or volume. The two balls have the same density. If you look at those two balls right there, this one right here is a golf ball, this one here is a ping pong ball. They both have the same size. The ping pong ball and golf ball is about the same size, but one is more dense than the other. And the reason why this one is more dense, the golf ball is more dense, is because there's more matter inside of there. And there's less matter inside of the ping pong ball. Okay? So we talk about that. Also, when we talk about liquids, we can divide liquids into layers as well. This picture here is a picture you have in your book as well. What you're seeing here is actually, this would be the densest, and it kind of makes sense if you think about it. This is the densest layer of liquid, the next dense, next dense, next dense, next dense, and least dense layer of liquid. Okay, and it kind of makes sense if you think about it. Something that's heavier is going to sink to the bottom. Something that's lighter is going to stay on the top. So when we talk about density in liquid, the heavier the liquid, the more dense that liquid is, the deeper down it's going to sink. All right. Also, knowing density of substances can help us determine what kind of substance it is. So, talking about solids, knowing what kind of substance is and the density of that substance can help us identify. If you remember back to these balls right here, one is 46 grams, one is 2 grams. Being able to identify the density of those, that will help us to determine the density of solids as well. Now, how do we find density? Well, density is a very simple math equation. It's density equals mass over volume. All right. So you put the mass over volume, and that helps you find out that helps you find out what density is. So typically, you're going to be given on TCAP and stuff. You're going to be given, or TN Ready, whatever it is this year. You're going to be given this information. You just have to solve this information. Just remember that mass is over volume, and that'll help you find out the density right there. All right. Here's an example of densities of common materials. Now, we use densities to help us determine and help us to find out different types of materials. So if you look on this chart right here, you can see that there's a huge difference between the density of water as there is compared to mercury, or helium as there is to oxygen. So all these have their own specific densities, all right? And that helps us determine the different type of product. If you didn't know what the liquid that you were looking at, if you didn't know that it was water, but you knew the density of water was 1.00, and they told you density of this specific product was 1.00, that tells you then that it's water. That's the density of the water. It helps you identify that substance. Now, here's some math things right here that you guys can do to help you figure out for density. Now, we need to understand that when we have physical changes do not form new substances, okay? So when we talk about physical changes and substances going through physical changes, they do not change they do not change the identity of the substance. So here's a sheet of paper, okay? Now, this is a sheet of paper right here. Everybody can agree to that. That's a sheet of paper. If I took that sheet of paper and I did this, what is it? Well, it's still paper. If I took this sheet of paper and I did this, what is it? It's still paper. If I took this sheet of paper and I did this, it's still paper. I did this, it's still paper. I did this, it's still paper. All right. I did not change the identity. I didn't create a new substance. All right. All I did is change the size of it. I just changed one of the physical features of it. I did not create a new substance by doing that. All right. That is what a physical change does. A physical change does not change the identity of the substance, does not create a new substance either. Okay. So that's one thing we need to understand. Physical changes do not change the identity of the matter involved. Well, hey guys, guess what? That's the end of the video. This is your 7.2 review. I'm going to be quiet while you sit down and take some notes off of that. You guys, I will be quiet for a few minutes. Well, I hope you guys enjoyed that video. This is your 7.2 section video. It's me, Mr. Lewis, your teacher. You guys have a great day, and I'll be seeing you in the future.